All right, so in this video, I'm just going to say a little bit briefly about sort of IVPs for linear systems. So these are pretty similar to previous examples of IVPs we've had to work with, but I just want to walk through maybe two problems to see how they work. So we're given some equation like this. I'll sort of rewrite it. So x prime equals 5x and y prime equals 3x minus y plus 2e to the negative t. So we can go ahead right away, just see, okay, x equals c1 e to the 5t. Which means y prime equals 3c1 e to the 5t minus y plus 2e to the negative t. We go ahead and solve for y now, right, using integrating factors, and we just get y is equal to 1/2 c1 e to the 5t plus c2 e to the negative t plus 2t e to the negative t. All right, so I'll write this back in matrix form. So x is equal to e to the 5t c1. Then we have a 1 and a 1/2, right, from this sort of invisible one there and that 1/2 there, plus c2 e to the negative t, and then we have a 1 there, nothing, and a 0 in the x over there, so 0, 1, and then plus this sort of unattached term, which we can just say 2t to the negative t 0, 1. Can pull it out, I could leave it in, doesn't really matter for that one. Okay, so we have our general solution. But now let's go ahead and actually solve for the IVP. So I'm also going to rewrite this just because, who likes dealing with fractions? Can rescale this vector to 1. Okay, and now we're given our initial condition, which is that x0 equals 2, negative 2. So x0, right, we need 2, negative 2 to be equal to positive c1 e to the 5t, or actually e to the 5 times 0 times the vector 2, 1, plus c2 e to the negative 0 times 0, 1, and then plus 2 times 0 e to the 0, again 0, 1. So we'll simplify this. And now I'm actually going to move our c1 back inside. So 2 c1 plus 0 c2, and then plus, well, there's a 0 in front of that, so that's just going to be 0, 0. And now if I just sort of treat this as two separate equations, 2c1 equals, or 2 equals 2c1, and negative 2 equals c, how did that become 2? c1 plus c2. Pretty easy system to solve. c1 equals 1, which means c2 equals negative 3. And now our final answer, again, sort of extra important here, we're going to want to plug these back in. So our answer is, well, C1 is just 1. E to the 5t times 2, 1. And then minus 3 e to the negative t, 0, 1. And then plus, well, there wasn't even a coefficient, so just 2t e to the negative t, 0, 1. And I could be done there, or if I want, I could just do one more round of sort of some simplification. And write it like that. Okay. So pretty straightforward. I mean, once we have the general solution, it's not that much more difficult to find the C1 and C2. It's just it becomes algebra at that point. Right, I will do one more example before I end the video. Okay, so again, we have x prime equals negative tangent of t times x, and y prime equals 2x minus tangent of t times y. So we can go ahead and solve well, what's the integral of negative tangent of t? If you write it as sine and cosine, you can see that it's a pretty simple u sub. If you set u equal to cosine, and we get our answer is e to the natural log absolute value of cosine of t. And so x, if we simplify that once more, is just some constant c1 times cosine of t. All right, if we do a similar process with y, we would get that our general solution for y is negative 2 t c1 cosine of t plus c2 cosine of t. And once we have that, we can write it back in this form. C1, I guess we can call it the cosine of t as well. 1 negative 2t, and then plus C2 cosine of t 0, 1. Right. So now we'll go ahead and solve for C1 and C2. So negative 1, 4 equals C1 cosine of 0 times 1 negative 2 times 0 plus C2 cosine of 0, 0 times 1. Math on this one works out to be incredibly simple. We just end up with C1 is -1 and C2 is 4. And now I can write my final answer. I'll bring the negative inside. So -1 times 1, -1, -2, t times 1 is 2t. And then plus C2 cosine of t, whoops, nope, shouldn't have written the C2, 0.4. All right, I will leave you with a single exercise. All right, so give that a shot. All right, going over the answers real quick. You should have gotten that for your general solution, that x of t is equal to c1 e to the 2t, say 1/3, plus c2 e to the -t, 0.1, and your specific solution should be e to the 2t, 3.1, plus e to the -t, 0.7. Right, and we will end it there.